let's talk now. This is going to be a pretty short lecture, so hopefully it can keep your interest for a little while. I'll send some problems to complement this to help you practice. Let's talk finally now on special positions related to the double bond. This is going to become very important when we start getting into chemical reactions, organic reactions, and things like NMR spectroscopy late in the semester. So there's a few positions related to the double bond that you need to know. The sp3 carbon. Uh-oh. Let me change markers. Okay. The first sp3 carbon. Okay. Away from the double bond. It's called the allylic carbon, or allylic position. Okay. Allylic carbon, or allylic position. Okay. If we attach a bromine to that carbon, we could say it's an allylic bromide because the bromide is attached at the allylic position. So here is another example of an allylic carbon. Anything directly attached to a carbon of the double bond, in this case it's hydrogens. Okay. This is the vinyl position. Okay, therefore these are called vinyl hydrogens. Okay. So one carbon away, this sp3 carbon is an allylic carbon. Okay. Anything attached to it is attached at the allylic position. Anything directly attached to the carbon of the double bond is in the vinyl position. So in this case, hydrogen it's a vinyl hydrogen. So let's see if we can look at an example. So in this case, circle the vinyl bromide. Circle the vinyl bromide. Vinyl, remember, is directly attached to that carbon. So this bromine is directly attached to the carbon of the double bond. This is a vinyl bromide. Okay. Now, if I had to put a square around the allylic bromide, you would have squared this. Okay? The bromine there, because it is bonded to the allylic carbon. So this is an allylic bromide. Okay? What kind of hydrogen would these three hydrogens be called? They're attached to the allylic carbon. They're at the allylic position. So they are allylic hydrogens. Okay. Finally, this hydrogen is directly bonded to the carbon of the double bond, so it is a vinylic hydrogen. Okay. Vinylic hydrogen. This can get a little bit complicated, but you'll see it in common naming. Okay? So for example, you can treat this group where it's connected to something. Okay, something over here is directly connected to the carbon of the double bond. This is a vinyl group. Okay? Or we could write like this. Okay, what would that be called? What would that be called? Now something is going to be directly connected to a carbon that's one away from the double bond system, from the pi system. This is an allyl group. Okay? So if you were asked, for example, to give the structure, okay, give the structure of vinyl cyclohexane. How are we going to go about drawing that? This tells us we have a vinyl group and a cyclohexane group. So cyclohexane is directly connected to the vinyl group. So you can draw the vinyl group. What's right here? What goes right here? What's directly connected to the vinyl group? It's cyclohexane. That's it. It's vinyl cyclohexane. Okay. How could you name this using similar notation? What would you name that? Or give me both ways. Give me IUPAC and common name. Okay. So this chlorine substituent is directly attached to a carbon that is one carbon away from the double bond. So this is an allyl group. We could call it allyl chloride. Okay. For IUPAC naming, it would be 1, 2, 3. 3 chloro, 1 propene. 3 chloro, 1 propene.